Dear students, today in this module we will be discussing about characterization of waste. In the previous modules you might have studied about waste, its sources and what are the different sources from which the waste are being generated like your residential, commercial, institutional, industrial and so on. Then you might have studied about the composition of waste. Composition which includes like what are the different components of the municipal solid waste like plastic, paper, cardboard, glass, metal and so on. In this module we will be discussing about characterization. Characterization is nothing but knowing or learning about the property that the waste is possessing. Properties in the sense the physical property, chemical property and the biological property. So, we will be discussing about these property of waste in this module. Now, why it is essential to know or characterize the waste? One, with characterization you can decide what type of treatment you can give to the waste. Also, the energy potential which is available in the waste material, that also can be identified based on the characterization of municipal solid waste. With this introduction, now let us look into the learning objectives of this module. Now, the learning objectives of this module include to understand the concept of waste characterization and its significance. Then, to know about the method of waste characterization. Now, as I told you earlier, waste characterization is essential because waste contains a lot many components in them. It is a commingled or a mixed sort of waste where you have the biodegradables, plastics, cardboards, metal, glass, paper and many other inert material like dust, silt, sand and so on. Now, when you characterize, this again gives you the property of the materials which is there in the waste stream. Now, as I told you earlier, again why do we do this characterization? One is to determine the method of waste treatment and disposal, and second to identify or determine the energy generation aspect of the waste material. Now, there are three different types of characterization which is done. One is physical characterization, second one is your chemical characterization and the third one is your biological characterization. Now, we will discuss each one in detail. Now, the physical characterization includes parameters like identification of your moisture content that is present in your waste material, the particle size, waste density, their pH, temperature, field capacity, porosity and permeability. The characterization is important and it will help you identify the extent and the rate of degradation that the waste might undergo. So, let us discuss about the moisture content. Now, the moisture content of a solid waste is nothing but the weight of moisture per unit weight of dry or wet material. In the wet weight method, the moisture is generally expressed as percentage and in the dry weight method, it is expressed in terms of percentage of the dry weight of the material. In the wet weight method, the moisture in the sample is expressed as percentage of wet weight of the material, while in the dry weight method it is expressed as a percentage of dry weight of the material. Now, the wet weight moisture content is given by the formula moisture content is equal to A minus B by A into 100. A is nothing but your initial weight and B is your final weight, and when you subtract the final weight from the initial weight and you divide it by the initial weight into 100 will give you the moisture percentage which is present in the sample. Now, moisture is one critical parameter. It helps you in identifying or what type of process you have to choose for the treatment of this municipal solid waste. You can use moisture as one important parameter. So, moisture is a critical parameter that determines the economic feasibility of waste treatment. Example, you can talk about incineration. Now, incineration is a process of waste treatment where your waste is combusted at a very high temperature in the presence of oxygen. Now, when you are combusting, you have to apply a lot of heat to burn the waste. Now, if you have more moisture content in them, you have to apply the temperature accordingly. So, in that case moisture content plays one important role. In addition to that, another example if you see, while processing also moisture content is very important. Now processing in the sense, for example, if you are going for volume reduction by compaction, if you have too much of water in the waste, it will ooze out. And another way by which moisture content is important, like when you choose the biological conversion route like composting or anaerobic digestion, in those conditions also moisture content is very essential, because these processes require some amount of moisture content which will be supplied by the solid waste. What I mean to say is, if the moisture content is already present, then you do not have to add it externally. Okay. So, in general if you see any solid waste, municipal solid waste, it contains around 20 to 40% of moisture in them. Now the moisture again which is present in the waste depends upon the climatic condition of a particular region. If the waste is collected from an arid climate, it will be dry, and if it is collected from a region where there is high precipitation, then it will have more amount of moisture in them. Next important parameter is your density. Now density of a waste is defined as its mass per unit volume, which is generally expressed as kilogram per meter cube. Now it is again an important parameter for designing a number of elements in a solid waste management system. Now in the previous module we have discussed about the waste collection. Now in that again I told you how waste collection is one important component of a solid waste management system. So it is very important for designing the element of a solid waste management system. Now in waste collection, you can decide what is the type of waste collection vehicle. To choose the type of waste collection vehicle, then you should know the density. Also, what is the storage container, what should be its size, how are you going to transport, everything depends upon the density. So once you identify the density of the waste material, then you can easily choose the collection vehicle, storage container and the means of transportation which you are going to use. Even while designing your landfills are nothing but they are a controlled environment where you contain the waste or store them so that it does not pollute your environmental matrices like your air, water, soil and so on. So even while designing your landfills, density has to be taken care of. So during the different steps of waste management, starting from your collection to disposal, density of the waste keeps changing. So at every point of time, you should know what is the actual density of the waste. Now, why does the density keep changing during the process, like starting from your waste collection, then transfer, then processing, treatment, disposal. So, from the time it is generated till it is being disposed, for the density to keep changing. One is your scavenging due to these microorganisms, then due to decomposition, or sometimes handling also changes the density. Even during vibration of vehicles like the wetting and drying and during weather seasons, all these things contribute to changes in density of the waste. Now if you see, in a high income country, the collected waste will have typically low density because it contains more amount of recyclables. Examples are cans, glass, paper and so on. So in that case, what will happen, you get a considerable benefit which is derived through the use of these compaction vehicles on collection routes, where you need 75% reduction of volume is achieved. Now in low income countries, initial compaction is not favorable because the density is very high. Now compaction vehicles offer little or no advantage, and it is not so cost effective option. Next comes your particle size and distribution. Now this again plays an important role when you plan to recover certain materials from the waste materials. So recovery of waste materials is a key element in a solid waste management, and for this the size and distribution plays a very important role. Now this will help in selecting the waste processing method too. Like for example, what type of separator you have to use, whether you have to go for magnetic separation or air classifiers, and what type of shredders, are you going to go for shredding, grinding, crushing. So all these things will be determined by your particle size and distribution. Now the particle size and shape of these municipal solid waste is really challenging job to measure. Now because due to their complex shape and movement, generally it is very difficult to be sieved. You all know, like the size or the particle size is generally identified conventionally using a sieve analyzer. So in that case, the waste as such, if you see, they are of different shape and size. So, in that condition what happens is it becomes very difficult for the material to get sieved out through the sieve analyzer. Also, if you see, the movement of these waste materials through the sieve depends on certain forces acting on it. Now, the major means of controlling particle size is only through shredding. So, if you do shredding, then you will have a uniform particle size, and shredding has a lot of advantages also. Now, when you do shredding, it will increase your homogeneity, one. Second, it will increase your surface to volume ratio. Then it will reduce the potential for the liquid flow paths through the waste. Then particle size will also influence your waste packing densities. Now, you can find a uniform packing density to a certain extent. Now, the particle size reduction done by shredding also can favor like more amount of gas production, better composting when you choose these biological conversion route, because uniform particle size, then the surface area keeps increasing and the bacteria can act more efficiently, and they can produce more amount of biogas when you apply anaerobic digestion, or it can provide better or faster composting when you apply composting as a treatment process. Now, it also has another side. See, the flip side you can say for this size reduction or the shredders when you use is that the smaller particles generally allow higher packing density. Now, what happens is, like when it is tightly packed, the movement of water gets decreased. Moreover, the bacteria also, it becomes difficult for the bacteria to access the substrate for its food requirements. Therefore, it is always important that the particle size should be known to choose a better treatment method. Next important physical parameter is the field capacity. Now, field capacity, it is a critical physical parameter, and it is nothing but the amount of moisture that is retained in the waste sample against the action of gravitational pull. For example, any material will have some holding capacity. After that, what will happen? The water keeps oozing out of that particular material. The same thing is applicable here also. The waste as such, if you see, it will have some amount of moisture, it will retain it, but once it starts degrading, it will release a lot of water, and the water cannot stay back in the material and it will get oozes out. This is called as your field capacity. Now, the field capacity determines the formation of leachate in landfills. So, the water that is in excess of field capacity will always be released out from the waste material as leachate. In addition, the release of water from the waste will also be influenced by the applied pressure. So, if you apply pressure over this waste material, again the water will ooze out, and moreover, as I told you, decomposition also favors the oozing out of more amount of leachate from the waste material. So, the field capacity of uncompacted commingled waste from residential and the commercial sources generally range from 50 to 60%. Next important parameter is your permeability. Now, permeability is defined as a hydraulic conductivity of compacted waste. It is again an important physical property. The movement of liquid and gases within the landfill is determined by the permeability of the waste. Now, the permeability depends on a number of factors like your pore size, surface area, and the pore size distribution. Generally, permeability is inversely related to density. I mean, more is the density, then the movement will be restricted, which implies that the denser refuse are less permeable. The permeability of refuse ranges from 10 to the power of -1 to 10 to the power of -5 centimeter per second. The another important parameter, physical characterization of waste is the porosity. Now, just like permeability, it is again defined as the amount of voids per volume of waste. Now, higher the porosity, more will be the permeability of your waste, and the porosity of waste generally ranges from 0.4 to 0.67. Now, the porosity again keeps changing when you do compaction. When you try to densify your waste, or when you press your waste, obviously the pores or void spaces will be lost, and thus the porosity again depends on compaction as well as on the composition of waste. Composition of waste, maybe you can take it as an example. If you talk about these inert materials like the street sweepings and all, if you see, it will have a lot of sand and silt and all, there the porosity will be high. But if you talk about some the plastic or papers and all, there the porosity will be little less. Now, in the previous section, we discussed about what is the importance of waste characterization, and we discussed about many parameters of physical characterization like your porosity, permeability, particle size, then pore size distribution, then we discussed about the moisture content, then we discussed about the field capacity and so on. Now, we will be discussing about the chemical characterization of waste. Now, just like your physical characteristics, chemical characteristics are also very essential. So, now let us discuss what are the different chemical characteristics which are available. Now, chemical composition of solid waste is very important, because as I told you, again it determines the alternative processing and recovery options which are available for the waste material. Especially when you look at the waste to energy process, where waste is used as a fuel, there the chemical analysis or chemical characterization plays a greater role. In such conditions, you need a proximate or a ultimate analysis of the substrate. Now, if you have a proximate and ultimate analysis, then you can identify what is the energy potential of a particular waste material. Now, let us see what is a proximate analysis. Now, proximate analysis includes the identification or analysis of the moisture content, ash, volatile matter and fixed carbon contents. Now, moisture content we have already discussed. Now, how will you perform this moisture content? Nothing, you take the sample, it is just identified by drying 1 gram of sample at 105 degrees Celsius for 1 hour. The weight loss is generally expressed in percentage of initial weight of sample as percent. Like as I told you, moisture percentage will give you the weight loss divided by the total weight of the sample into 100. This will give you the moisture percentage. The next one is your volatile matter. Volatile matter is the amount of waste converted to gases as a result of combustion. Now, volatile matter is the weight loss that is obtained on heating 1 gram sample of substance at 950 degrees Celsius for 7 minutes in the absence of air. Now, here the weight loss due to the volatile organic matter or the removal of gases is given by total weight loss minus the moisture percent. So, the volatile matter in terms of percentage is given by weight loss due to the volatile matter divided by the weight of the sample into 100. Next important parameter in proximate analysis is the ash content. Now, ash is nothing but the residue that is left out after combusting a specific weight of the waste material in 700 to 750 degree Celsius. Now, ash percentage is given by the weight of residue divided by weight of the sample into 100. So, that will give you your ash percentage. Next parameter is your fixed carbon. Now, the fixed carbon is a material which is other than ash that does not vaporize when heated in the absence of air. It is usually determined by subtracting the sum of the first 3 values, that is moisture, ash and volatile matter in weight percent from 100. That means, fixed carbon is given by 100 minus when you add moisture, ash and volatile matter, that gives you the carbon content, I mean the fixed carbon content. Now, this table provides the proximate analysis of the municipal solid waste. Now, in this table if you see the moisture content, I mean a typical municipal solid waste contains a moisture content of 20%, volatile matter of 53%, fixed carbon of 7% and glass, ash and metal of 20%. Another parameter is your fusing point of ash. Now, the fusing point of ash is defined as a particular temperature at which the ash results from the burning of waste will form a solid clinker material due to fusion or agglomeration. Now, generally the fusing temperature for the formation of these clinkers is 1100 to 1200 degrees Celsius. So far we discussed about the proximate analysis. Now, we will see what are the ultimate analysis, what are the components which are part of the ultimate analysis. Just like your proximate analysis, there are many components which form your ultimate analysis, like your carbon, hydrogen, oxygen, nitrogen, sulfur and ash. Now, due to the concern over the emission of these chlorinated compounds during combustion, the determination of halogens is also included in the ultimate analysis. Now, the results of ultimate analysis are generally used for characterizing the chemical composition of the organic matter present in the municipal solid waste. They are used to define what is a proper mix of waste material to achieve suitable carbon nitrogen ratio, especially when you use a biological conversion route for treating your waste. Biological conversion route means example composting, then biogasification, anaerobic digestion, vermicomposting and so on. Now, the analysis of these carbon, hydrogen, nitrogen, sulfur is generally done using a CHNS analyzer, and ash is determined by the method which is mentioned there in the proximate analysis, like by heating them at a temperature of 700 to 750 degrees Celsius, that will result in the formation of ash, and then you can quantify, that will give you the ash content. Now, next parameter or the chemical parameter is the heat content. Now, why do we have to calculate the heat content is like it gives the calorific value of the waste material. Now, when you know the calorific value, you can understand what is the potential, energy potential that is locked in each particular waste. Now, calorific value is defined as the amount of heat that is generated from combustion of a unit weight of a substance. They are generally expressed in kilocalories per kg. The calorific value is generally determined using a bomb calorimeter, which is the heat generated at a constant temperature of 250 degrees Celsius from combustion of a dry sample. Now, since this test temperature is below the boiling point of water, the combustion water remains in the liquid state generally. During combustion, the gases remain above 100 degrees Celsius, so that the water resulting from combustion is generally present in the vapor state. Now, this table, if you see, that this gives the heating value of some of the solid waste material. For example, the heating value of your food waste is around 4500 kilocalories per kg. Same way for paper, it is 16,500, plastic 32,500. Likewise, it is listed for cardboard, textiles, rubber, leather, garden trimmings, wood, glass, metal, ferrous and non-ferrous, dirt, ash, bricks and municipal solid waste. Out of this, if you see, plastic contains highest heating value, like 32,500 kilocalorie per kg, and lowest, it is obvious, it is present in the metals, and municipal solid waste like the commingled waste or mixed waste contains around 10,500 kilocalorie per kg of heating value. The next parameter under chemical characterization is your essential nutrients. Essential nutrients are generally analyzed to find out what is the composition or what is the nutrient level that is present in the waste material, so that it can support the growth of your microorganisms. So, it is essential when you are going to use this waste material as a feedstock for the production of compost, methane, ethanol and so on. So, when you identify these elements, that will help you in knowing whether this will support the microbial growth or not, and whether you can prefer your biological conversion route or not. This data is obtained when you characterize the essential nutrients that are present in the solid waste material. So, physical characterization, chemical characterization and biological characterization is nothing but you identify what is the organic fraction of waste that is present in the waste content. If you do that, it will help you in identify what is the biological conversion route you have to suggest for the waste that is being generated in your locality. To summarize, at the end of this module, we have discussed about what is characterization, why waste characterization is important. Like as I told you, when you do or when you understand the property of the waste material, you can identify what is the nature of treatment you can give for the waste material. Also, you can decide how you have to dispose this particular waste. Moreover, you can also identify what is the energy potential that is locked in this particular waste. Then I told you there are three different characterization of waste which is there. One is your physical characteristics, under which we studied about the moisture content, we studied about the permeability, porosity, particle size, distribution and so on. Then we discussed about the chemical characteristics, where we discussed about the heating value, ultimate analysis, proximate analysis, what are the components of these ultimate analysis and proximate analysis. We also discussed about the fusing point of ash. Then Lastly, we discussed like what is the significance of the waste characterization based on which whether you can choose your biological conversion route or you are going to go for any other thermal treatment method. I hope this module would be of help to you. Thank you.